What's going on, Clarity Coders? Sorry about the wait. Today we're going to be jumping back into OpenCV and taking a look at template matching. Template matching is a technique we can use to detect images inside of another image without training a neural network. I'm going to walk you through a simple example line by line in a Jupyter notebook to explain and show you the technique. Then we're going to apply that technique to a simple game to see if we can get Clarity Coders on the leaderboard and kick your chop. Can we top that leaderboard? Let's jump right in and find out. Now in this part, I'm going to walk you through a simple example of template matching in OpenCV. So for this, we're going to use OpenCV obviously and NumPy to get our example done. So if you haven't already, you want to copy in this line, which is just to pip install OpenCV. Now, if you've been following along with the tutorial series, you should already have this done, so you'll probably see something like this where it says requirements already met. Then we can pull in the two libraries that we're going to use for this project. The two libraries that I'm going to use for this project are CV2 and NumPy. Now, in the later applied template example, we use some other libraries to detect keystrokes and things like that, but in this example, we're just going to use these two libraries. And you can hit Shift-Enter to run that as well. Now inside of the GitHub, I'm going to have the images that we're going to use. Now typically what you're going to see when you do template matching is you're going to see a source image. Now you can imagine that as a live camera feed or some type of original image that you're looking for another object inside of. So you've probably seen ones where you detect a mask or you detect an eyeball or whatever it is out of the image. We're going to call these our farm image and our wheat image. So if you look at these images, it's just a simple game like a farming game. And we're going to try and pick out the different instances of wheat inside that image. Now this is a little tricky because some of the wheat images are covered up by other things and sometimes there may be different shades. Maybe the game turns from day to night or something like that. And you can imagine this in a real world setting as well. If you want this notebook, this code, or these images, they're all in the GitHub in the Lesson 3 folder, so you can grab them from the description. We're going to run Shift-Enter and pull in our two images. Now, these are in the same directory as the script, so you'll notice I'm just referencing the image, the file name directly. And then to show these images, I'm going to create a couple more blocks of code here. This is going to be to show our farm image. You can see that we do CV2 wait key. Now that's going to allow it to stay up until we hit a key and then destroy all windows. This is something that I have to do in Jupyter notebooks so it doesn't freeze the notebook. So if we do Shift-Enter here, you can see it appears just to hang, but if you look down in your taskbar, you should now have an image pulled up. And you can see that this is going to be our original image, and we're going to try and detect wheat images out of it. So now what I've done is I've created a needle image, what a play on needle in the haystack. So we're going to look for an image inside of this image. Now what I did was straight out of this image, inside Paint, I just cut out the wheat image that we're going to look for. Now my hope is that we detect multiple instances of wheat and then we can do something based on that information. Maybe if it's like a security camera or something like that, we throw an alert. If it's something like you're creating an automated game or whatever it is, maybe you're clicking in that location to harvest the wheat. Next, let's show our needle. So the needle in this case is this tiny image here. You can see it is literally something that I cut out of our original farm image. So that's what we're going to be looking for. We'll close that as well, and we'll reference these back a couple times when we're going through this demonstration. Now, for template matching, what we're going to do is we're going to use different algorithms that I'll show here to try and see a match in our image. So we're going to try and pull out features in a match. Now, I'll note the docs here, and you can read up on each different type of method, and there's a lot of mathematics that goes along with it. But essentially what we're going to do is slide our needle image across our original image and try to find a match. Now for each of those locations that we test, we're going to get a value back that's how close of a match it is. So what you're going to see is when we originally do this, you'll see almost like a heat map that shows where the best matches are. So let's go ahead and take a look at what that looks like here. So what we can do is we can choose one of the 6 template matching algorithms to use, and then we can run it and get our result. So what I'm doing here is I'm doing cv2.matchTemplate. I'm doing the image that we're looking for the needle inside of, which is our farm_image, and then our needle image itself. So this is what I'm looking for, which is the wheat image. We can run this, and I've also picked one of the algorithms to use. You can use whatever one you would like. If you're doing this in a real-world project, I would suggest testing them all and seeing what works best in your case. Now this is pretty cool. We can actually grab that result and show it to the screen just like our other items. So what I'm going to do here is I'm going to do IAmShow again with our result, the same exact wait key, destroy all windows. And if we look at this, you'll see at first it doesn't look very useful, but if you look a little bit closer at this image, you'll notice it's a black and white image and there's some white markings along it. You can tell where it's lighter and where it's darker. So these light images are where there's a closer match. Now, if you look closely and overlay our original image here, you can see that it picks out 5 pretty distinct white points. Now, those white points are where the wheat is. So we know we have something going here. This is a pretty good, it's finding some pretty good results right now. So if we want to get our best matches back, we can use cv2.min_max location on our result. So what this is going to do, it's going to return 4 things. It's going to return the minimum value, so that's the worst match of all the matches, the maximum value, which is the absolute best value of the best match. It's going to return the min location, so that's the location of the worst match, and the max location, which is the location of the best match. So if we run this, we're going to get some values back, and one of those values is our max location. Now this is very useful. This is the XY coordinate of our best match. So with that, we can draw a rectangle around our original image to highlight where our best match was. So let's go ahead and take a look at that. And actually, before we take a look at that, let's also look at our max. This is our max location. Let's also take a look at our max value. Now you'll notice that our max value is a 0.999% match, which is really good, right? Which makes perfect sense because I literally copied and pasted the image from it. So it should have a pretty good match. So we're going to use that later. So we're going to say a threshold of what is a good enough match. So obviously in real world examples, you're not going to get a 9999% match very often. So what is a good enough match that we still think it's wheat? That's what we're looking for here. So with our best match, we're not quite to the multiple matches yet. Let's try and draw a rectangle around our best match. Now, if you remember, when you're drawing rectangles, we need to define a top left point and then a bottom right point. Well, we have our top left point here in our max location. We need to define a bottom right. So one thing I know is how big my wheat needle image was. So I'm going to get the width of my needle image, the height of my needle image, and then I can add those values to my max location to get the bottom right point on the image. So now that we have the width and the height, let's go ahead and create our rectangle. So to create our rectangle, you might remember we're going to do cv2.rectangle. We're going to pass in the image that we want to draw the rectangle on. We're going to pass in our top left point, which was defined up here in max location. And then we need to define our bottom right point. Now this is a little different. So we're going to take the X value out of max location, which was in the 0 index, and we're going to add the width to it. Then we're going to take the max location that was in the 1 index, which is the y-axis, and add the height to it. Then we're going to draw a box around that. And this is just color and line thickness, if you remember from our last video. Now we can do Shift Enter. You'll get some output here. And if we go back, we can display our farm image again. So I'm going to go up to the cell that had our farm image. And you can see that our best match was right here, which is probably where I cut the image out of. Now you're saying, great, we found the exact image. That doesn't do us a lot of good, right? We want to find similar images if we're creating a farming game, or if we're saying, do something when you see a mask, it's not going to be the same mask every time, or something like that. So what we're going to do is we're going to now define a threshold so we can hopefully highlight all the ones that are close enough matches that we think it's wheat. I'm going to close this. Now remember, every time we do something different, we want to reload in our images. So I'm going to run this cell, and I'm doing that so we no longer have our yellow marking on that. And now we can go ahead and create our threshold. Now I've done this ahead of time, so I'm just using a threshold that I know works pretty good at finding the different images. You're going to have to play around with that in your example. It might be 85, it might be 60, maybe it's 40. So what you know is if you have too many false positives, you want to try and increase your threshold, make it harder to find a match. If you don't find all the things you want to find, you might want to lower your threshold to find more matches. So what we're going to do is we're just going to use a threshold of 60. Now we can do some NumPy arithmetic here, comparison here, and we're going to say where our result is greater than or equal to our threshold, we want to keep those locations. Now remember, that's going to return two different results. It's going to return a Y location and an X location, and then they're in the opposite order you would think. So what we're going to do is we're going to receive in some Y locations, and we're going to receive in some X locations here. Now, if we look at one of these, we can see about how many matches we have. So you can see that we got 13 matches here. We have 13 X locations and presumably, hopefully, 13 Y locations. So now to draw our 13 matches, which you're probably thinking, that's too many matches, right? He said this worked pretty good. Hang with me for just a second. So we're going to draw our 13 matches. What we're going to do is we're going to do a little for loop here. We're going to do for X and Y. You'll notice I put them in the correct order this time. In zip X location, comma, Y location. So again, I'm putting them in the correct order, X, Y coordinate. And I'm zipping them together. So I'm pairing each one together. So the first item in the X location is paired with the first item in the Y location to create our points. Then each time through this, I'm drawing a rectangle on the XY coordinate. I'm doing just what we did before. On the X coordinate, I'm adding the width. On the Y coordinate, I'm adding the height, and then I'm drawing the square. Now, if I run this, I can go back up and I can show our image again. And you'll see that we got all 5 of our wheat images. And you may ask yourself, well, we did get all 5, but it said we had 13 matches. You'll notice some of these have a thicker square around them than other ones, and that's because it's finding multiple matches. Now, maybe this isn't an issue in your program, or maybe it is. So what we want to do is show a way that we can limit it to just the one match. So essentially, we want each 5 to show up, but we don't want multiple highlights over the same patch of wheat and that sort of thing. So we can use another algorithm built into OpenCV that allows us to group these together. So what we want to do is we want to create a group of rectangles, and then we're going to use a function that's built in to combine those rectangles if they overlap. So what is a rectangle? Well, in OpenCV, in this algorithm, it wants an X coordinate, a Y coordinate, a width, and a height for each rectangle, which is pretty easy. That's basically what we have anyways. So we're going to create a blank list to hold our rectangles. And remember here, we're trying to look at another way to do this. So I'm going to reload my images. So you want to reload that image. So we're back to a clean slate here. And this time, each time through our for loop, instead of drawing the rectangle right away, we're going to append the rectangle to our rectangles list. So you'll notice we're doing rectangles.append each time, and inside of this, we're using square brackets, so it's a list inside of a list, and we're defining it just like OpenCV wants, X, Y, width, and then height. And each one I'm converting to an integer to make sure we're not going to blow up this function down the road. Now, one other thing you'll notice is in our case, not every rectangle was duplicated. One had just a single square over it. That's going to be an issue. When the group function runs, it's going to want at least 2 rectangles to group them together, and that's not the effect we want. We want it to find all 5, even if a single rectangle is over it. Now, I've looked at the code and I've looked at a couple other forums, and there's basically one workaround to do this, and that's to duplicate the rectangles. So we're gonna make sure that it has at least 2 on it by putting every rectangle in there twice. So we're literally gonna copy this line, paste it below, and that will duplicate the rectangles as it puts them into our rectangle list. So if we run this, then we can run length of rectangles, and you can see that we got 26, which makes sense because we did duplicate those. Now we can pass it into our grouping function. So I'm going to grab a couple values out here, and you can read up in the documentation on these actual parameters and play around with it to meet your match. So basically what we're saying here is how many rectangles do we want in a group? We want just 1. So it's going to pare those down. And then there's a coefficient here that you can play around with that'll basically say how close it has to be to consider it a group. So how much of an overlap is okay to group them together. This is the parameter that I found was useful. Go to the docs right here and you can play around with these values as well in your own problems. So we're gonna go ahead and run this. And now we can take a look at the length of our rectangles again, and you can see that we're down to our 5, which is very promising. Now let's copy our function from above, our for loop that drew the rectangles. And instead of iterating over our zip this time, we're going to iterate over rectangles. And we're going to unpack from rectangles each time an X, a Y, a width, and a height. Now we can run this. Let's slide up and look at our farm image. And you can see perfect. We got 5 exact matches that look perfect for our image. So that's exactly what we wanted. Now this is a very simplistic example, but it gets you started and it shows you exactly how to do template matching. Now I wanted to do a fun little program just to highlight this even more. So what we're gonna do here is we're gonna take a look at another example of template matching really quick here. So I don't know about you guys, but in my childhood, I like to play a lot of these silly Flash games. Now they're mostly HTML5, but we're gonna use that to show another example of template matching here. This is called Kick You Chop. So the concept of this game is really simple. If you click on the left side, you break a branch off of the left side and your guy stays on the left side. If you click on the right side, he moves to the right side, and you need to avoid the tree branches that come down. I'm going to show you my best run here, or one of my best runs, on my way to getting the highest score in Kick You Chop. The program's really simple. It's just going to test using template matching to see if there's a branch above our man's head, and if it is, we're going to click the opposite side. You can see here that it's testing above the player's head to see if there's a branch there, and when there is, it's clicking on the other side. So I'm doing this using screenshots with MSS and then PyAuto GUI to actually click the screen either on the left or the right. You'll see the mouse moves on its own. Now I simply took a section above the player to test, so I needed to use a stick from the left side and a stick from the right side as my needle images. If I'm on the left side of the screen, if my player's on the left side of the screen, I use the left image. If my player's on the right side of the screen, I use the right image, and I only test whichever side I'm on, because that's the only time I'm worried about a branch hitting me in the head. Now, if you run out of time with the green bar on the top, you lose, and also, if you're on the same side as a branch comes down, like here, you will also lose. That's it for this time, everyone. Thanks for watching. If you haven't, please subscribe. It helps the channel. Let me know in the comments if you want to see anything special or in particular. And until next time, keep coding.